Lesson 33, before you start that, make sure you complete Test F in the Test Masters. This lesson deals with comparing decimals and rounding decimals. Let's just learn about comparing and rounding decimal numbers by working some practice problems. Look at practice problem A, B, and C. What I want you to do is just in those circles there between the comparison numbers is put a greater than, less than, or equal sign. Why don't you go ahead and pause the CD and see if you can figure out which of those pairs of numbers are greater, equal, or less than each other. On practice problem A, 7.4 is the same thing as 7.40. When you have a trailing zero, or they might call it an extraneous zero or an extra zero on the end, you don't concern or worry about that. You're not concerned about that for your answer. Remember, we've talked about before, when you're dealing with money, you always have two decimal places. Like if you had $7.40, you wouldn't write that down 7.4, you would put 7.40. But just make sure you understand that that zero doesn't really add anything to the value of 7.4. 7.4 is the same thing as 7.40. Sometimes it's just important to have that extraneous zero on the end. Now look at B. 3.08, that would be less than 3.80, because on the left the 8 is in the hundredths place. That's 8 hundredths. That's a lot smaller than 8 tenths. On the right side, that 8 is in the tenth spot. So 3.08 is less than 3.80. And then on C, you have a 1 on the left side in the tenths place. So that's 1/10. That's greater than 99 thousandths. Just think about it. You could make 3 decimal places on the left. You could put extraneous zeros, and you could think of that as 100 thousandths. That's bigger than 99 thousandths, right? Just barely, but it is bigger. So we'd put a greater than symbol there. 2.1 is greater than 2.099. And to help us understand that problem, we added some zeros on the left side. So remember that all of these extraneous zeros, we'll just use that word extraneous to mean zeros to the right or at the very end on the decimal side of a number. Any of those, all those ones I underlined there, those are all extraneous zeros. They don't change the value of a number. Now let's work on rounding some decimal numbers. And you learned about rounding back in lesson 29, where we talked about rounding whole numbers and mixed numbers as well. So hopefully you understand rounding pretty good. And remember our rules on that. You circle the digit that you're rounding to, and then you put an arrow over the digit to the right of that. If that digit is less than 5, then you don't change the circle digit. If it's 5 or greater, then you increase that circle digit by 1. Now you need to listen carefully to how I want you to round these different problems in order to do them correctly. On practice problem D, I want you to round that to the nearest 10,000th. So that means you need to circle the digit that's in the 10,000th place. So you start at the decimal point and you say tens, hundreds, thousands, 10,000ths. The 1 is in the 10,000ths place. Put an arrow over the 5 then. That means you need to round that 1 up to a 2, since it's 5 or greater. And you would have 2.873. 2. That's that number rounded to the nearest 10,000th place. On practice problem E, I want you to round that to 2 decimal places. So that means you circle the second decimal place. And whenever you hear that 2 decimal places, 3 decimal places, they're talking about to the right of the decimal point. So rounding to 2 decimal places will be 2 digits to the right of the decimal point. Circle that 4, put an arrow over the digit to the right. That's less than 5, so you don't round the 4 up. You just leave it as a 4. 37.34 is your answer. And on F, what I want you to do there is round that to the nearest whole number. So the nearest whole number is the one immediately to the left of the decimal point. That means we'll circle it. Circle that 8 right there. Put an arrow over the 3. That's less than 5, so that means we leave the 8 alone. Rounding to the nearest whole number would give us 88. Anytime you hear that word whole number, that means you don't have any fraction or decimal after it. Because remember, decimals are fractions, right? They're not a whole number. They're a part of a number or a fraction of it. Let's just do a couple of other things with rounding. On G, just simplify that. 11.33000. Simplify that by removing the extraneous zeros. And remember, extraneous zeros are the ones that are at the end that don't change the value of that particular number. And so we could just write that 11.33, and we can put that equal sign there because those two things are equal. Sometimes extraneous zeros are important. Sometimes they're not. It just depends on the application of that particular problem. Let's do one more problem. Now, one thing that rounding can help you do is to estimate an answer really quickly. And sometimes you don't need to know an exact number. You just need to kind of get close to give you an idea of how these values relate to each other. So on H, you have an addition problem there. I want you to just estimate that by rounding each value to the nearest whole number first. And hopefully you can do rounding pretty good now. You can just do these in your head. 2.2 would just be 2. 9.19 would be a 9. 11.597 would round up to a 12. And so we'd have 2 plus 9 is 11, plus another 11, actually a 12. 2 plus 9 is 11, plus 12 would be 23. That would be an estimate. That's not the exact answer. Estimate means to get close to what the exact answer is. The exact answer is 22.987. We estimated that by just rounding to the nearest whole number. And that was a lot faster than doing all of the addition that would be involved using the real numbers that we had there. And there's a lot of times in real applications using addition or just working with numbers that you don't need to know an exact number. You just need to estimate it. So rounding is an important skill to be able to do. Now there's some supplemental problems in the back for this lesson if you need some extra help on comparing and rounding. Okay, well that's all for lesson 33.